Welcome to the Deep Dive. We're the place you come to get the core knowledge from a whole stack of sources. Today we're digging into something pretty fundamental to every computer out there, memory. Specifically, we're looking ahead at system memory, DDR6, and also trying to clear up some, say, common confusion about graphics memory, GDDR. Maybe you've heard whispers about these new memory types, or perhaps you're wondering if you should hold off on that new PC build. Our mission today is simple. Give you a clear, realistic view of what's coming and what's already here. Cut through the noise, get you properly informed. So let's start with the basics. We hear these terms, DDR, GDDR. They sound kind of similar. What's the actual difference there?
Yeah, it's a great question because their roles are really very distinct. DDR is DRAM. That stands for Double Data Rate Synchronous Dynamic Random Access Memory. Quite a mouthful.
Yeah.
That's your computer's main system memory, your RAM. It's what your CPU uses for pretty much everything, general computing tasks. Think multitasking, running your applications, managing the operating system itself. It's really optimized for low latency, being responsive, and also energy efficiency. Crucial stuff for making your computer feel snappy.
Okay, so that's the main workspace. What about GDDR then?
Right. GDDR SDRAM is, well, it's a completely different beast. It's specialized video memory, VRAM. It's used exclusively by your graphics processing unit, your GPU. Its whole design is tailored for extremely high throughput, massive bandwidth, and parallel processing. Think about what a GPU does in gaming or 3D rendering.
Right. Tons of calculations all at once.
Exactly. It needs to grab huge chunks of data simultaneously.
Yeah.
GPUs can tolerate a bit more latency than a CPU, but their main need is just raw speed for accessing and processing massive blocks of data. Very different from how a CPU uses DDR.
Okay, got it. So DDR for the sort of general thinking, the brain, and GDDR for the heavy visual lifting, the eyes. Makes sense. And, you mentioned DDR. There's still this kind of perception floating around that DDR5 isn't really mainstream yet. Is that accurate?
Oh, absolutely not. That's a big misconception we really need to tackle. DDR5 memory has very rapidly gained traction. It is firmly established right now. I mean, look at the market. The global DDR5 chip market was valued around, $12.44 billion in 2024?
Wow.
And projections show it could hit maybe $45 billion. Some even say up to $75 billion. By 2033, that shows sustained growth. It's not some niche thing. And this dominance is clear in both consumer and enterprise. Servers and PCs alone, they're going to hold something like a 70% market share in 2025.
Yeah.
This isn't just theory, it's market reality. DDR5 is actively being adopted everywhere.
And it's not just for those super high-end expensive bills anymore either, right? The prices seem to have come down quite a bit.
Correct. That's been a huge factor in it going mainstream. The price drops over the past year or so have been significant. High-speed kits, 16 GB, 32 GB, even 64 GB DDR5 kits, they're very competitive now. Like, you can find decent 16 GB options around $145, maybe a 32 GB 6200 megahertz kit for about $170. Prices really seem to stabilize in late 2023, early 2024, hitting those accessible levels for most builders.
And the chip makers, Intel, AMD, they're fully supporting it now, too.
Yes, absolutely. Both AMD and Intel have made sure their latest CPU platforms are fully compatible. We're talking AM5 for AMD and LGA 1700, soon LGA 1851 for Intel. This broad platform support means consumers can actually, use DDR5 and get its performance benefits without hassle.
Okay, this is where it gets really interesting, though. You mentioned market share, but isn't there also a strategic shift happening with the big memory makers?
Yeah.
Something that's actually pushing DDR5 adoption even faster.
You're hitting on a really important point there. Why is DDR5 adoption accelerating maybe even faster than expected? Well, Samsung, SK Hynix, Micron, the big players, they are actively phasing out DDR4 production shipments. The plan seems to be ceasing them completely, somewhere between late 2025 and early 2026.
Whoa. So they're basically forcing the switch.
Pretty much. It's a deliberate industry move.
Yeah.
And we're already seeing the effect. DDR4 prices are actually surging in some cases. You might even find DDR4 costing more than DDR5 now.
Crazy.
Yeah, so it's not just a natural evolution. It's this concerted push that will effectively, compel a faster transition to DDR5 for anyone buying a new system. DDR4 is just going to become scarce and uneconomical. And this acceleration for DDR5, it kind of sets a precedent, but it also implies DDR5 is going to have a longer, more dominant time in the spotlight before DDR6 really takes over the mainstream.
Okay, that makes a lot of sense. So let's pivot to that then, DDR6.
Yeah.
With DDR5 now firmly in place, pushed by the manufacturers,
Yeah.
when can you, the average listener, realistically expect to actually see DDR6 hit the market?
Right, the road to DDR6, it's the next big jump. And it follows a pretty structured roadmap. The key player here is JEDEC, the Joint Electron Device Engineering Council. They're the global standard setters. Now, they officially published the LPDDR6 standard, that's the low-power version, mainly for phones and laptops, back on July 10th, 2025.
Okay, so that part's official.
Exactly. And that's significant because it's the first official spec to explicitly mention DDR6, showing the whole family is moving forward. But, and this is the important bit for desktops and servers, the full DDR6 standard isn't finalized just yet. JEDEX plans to publish those specs sometime in 2025. Initial drafts were looked at in 2024. Specification 1.0 is kind of anticipated by mid-2025, maybe Q2. And the final draft, probably late 2025, maybe even slipping into Q1 2026.
So, okay, spec finalized late 25, early 26. Does that mean we can run out and buy it then? History usually shows a bit of a delay, doesn't it?
Exactly right. If we look back, there's always a lag, a gap between the standard getting the final stamp and products actually being widely available on shelves. Take DDR5, for example. It took roughly a year for modules to become widely available after its initial announcement in 2020. So we'd anticipate a pretty similar timeline for DDR6. Even if those specifications are locked down by, say, early 2026, you probably shouldn't expect to see compatible modules or, importantly, compatible motherboards and CPUs widely available until late 2026. That's the absolute earliest, more realistic mainstream adoption. That's probably pushing into 2027 or maybe even later. We see this pattern all the time, like with PCIe 5.0 and 6.0. The specs were agreed years ago, but widespread consumer use is only just happening or still coming.
Right, the whole ecosystem needs time to catch up.
Yeah.
What about the big memory companies themselves? Samsung, Micron, SK Hynix. What are their own internal roadmaps suggesting?
Yeah, they're all actively working on it for sure. Samsung, back in 2022, had a roadmap pointing towards DDR6 availability around 2028. They talked about native speeds hitting 10 GBPs by 2027, though some reports mention maybe commercial usage starting in 2025, but that almost certainly refers to, initial high-end server or enterprise stuff, not consumer PCs.
Okay.
Micron's roadmap, at least as of late 2023, interestingly didn't even mention DDR6 until 2029 or later. That suggests a more conservative timeline. Maybe they want to really maximize DDR5's potential first.
Makes sense.
And SK Hynix, they seem focused on some really ambitious long-term architectural changes for future memory, including DDR6. So you see this consistent pattern. It points towards that tiered adoption strategy we talked about. New memory tech always tends to show up first in the professional grade stuff.
Servers, workstations.
Exactly. Enterprise CPUs, high-end workstations. Then it slowly trickles down to mainstream PCs, gaming rigs, laptops. It's a phased rollout. It lets them refine the tech, get manufacturing yields up, achieve economies of scale, and frankly, recoup those huge R&D costs before it hits the broader consumer market. So yeah, you'll probably see DDR6 in a fancy server room long before it's in your average desktop build.
So performance-wise, when it does arrive for us, mere mortals, what kind of leap are we talking about? How much faster will DDR6 be compared to DDR5?
Oh, it's poised to be a substantial gain, really substantial. DDR6 is essentially designed to double the speed of DDR5. The JDDIS standard targets data rates of 12,800 megatransfers per second, MTs.
Double. Wow.
Yeah, and that's just the standard overclocked modules. They're expected to push way beyond that, maybe reaching like 16,800 MTs. Some projections even suggest crazy speeds like 17,000, maybe even up to 20,000 MTs eventually.
Okay, it's hard to even picture. What does that mean in practical terms, just faster loading?
It translates into just massive increases in bandwidth. We're talking potentially 134.4 gigabytes per second at least. But it's not just raw speed. DDR6 is also expected to be more power efficient, operating at less than 1.1 volts compared to DDR5's 1.1B baseline, thanks to denser chips and better power management. And the architecture is changing too, a four-fold increase in memory channels compared to DDR4, at least 4 memory banks, each with these sort of sub-channels, effectively doubling the parallel paths DDR5 has. Think more lanes on the data highway.
More data moving at once, not just faster.
Precisely. Plus, DDR6 is expected to have much better error correction ECC, both on the chip itself and potentially off-chip too, improving signal integrity and capacities. We could see individual sticks, DIMMs, reaching 256 GB.
256 GB on one stick. Good grief. Okay, that's definitely looking ahead. Let's switch gears back to graphics memory for a minute. GDDR, you mentioned earlier it's distinct from DDR, but there's this other perception out there, right? That things like GDDR6, maybe even GDDR7, aren't really in high use yet.
Yeah, that's another one we need to clarify. It's really important to hammer home that GDDR is fundamentally different, purpose-built for graphics cards. It's all about handling that super high throughput for parallel tasks, gaming, rendering, AI. Like we said, GPUs pull huge continuous blocks of data, unlike CPUs needing quick access to small bits.
So that perception about GDDR6 is wrong. It was widely used.
Oh, completely wrong. It's fascinating, actually. GDDR6 is, in fact, the dominant memory standard for modern GPUs right now in 2024. It first showed up way back in 2018 with NVIDIA's 20 series cards.
Really? That long ago?
Yep. And it's currently in the vast majority of GPUs available today. High-end professional cards like the NVIDIA RTX 6000 Ada, the AMD Radeon PRO W7900, they use it, and even brand new cards coming out in 2024, early 2025.
Yeah.
Like ASRock's Radeon RX 9060 XT, AMD's whole RDNA 4 series, Intel's new Battle Mage cards, they're all still launching with GDDR6.
Why is it so dominant then? What makes it the go-to?
Well, it hits a sweet spot. It offers really high bandwidth, up to 16 gigabits per second per pin, which is way, way higher than even fast DDR4 system memory, like 3 to 4 times the effective bandwidth. It's also got better power efficiency than its predecessor, GDDR5, operates at 1.35V versus 1.5V. And crucially, its manufacturing cost has become really effective over the years, so it's the preferred choice for, well, pretty much everything from gaming cards to data center GPUs right now.
Okay, so GDDR6 is the established workhorse. Then what about GDDR7? That's the newest one, the next step.
Exactly. GDDR7 is the latest evolution. Introduced in 2024, starts showing up in products, well, basically January 2025. As of right now, early 2025, it is exclusively used by NVIDIA's new RTX 50 series GPUs. NVIDIA tends to be the early adopter for this cutting-edge GPU memory.
Oh, okay. So only on the very newest, highest-end NVIDIA cards for now.
Precisely. And it offers another big performance jump. Initial speeds are hitting like 28 gigabits per second on the RTX 5090, maybe 30 on the 5080, and the potential is there for much higher speeds later, maybe 40, even 48 gigabytes per pin. Plus, again, better power efficiency down to 1.2V compared to GDDR6X's 1.35V, and higher density, so more VRAM capacity.
So if it's that much better, why isn't everyone using it yet? Why are AMD and Intel sticking with the GDDR6 for their 2024-2025 cards?
Cost, mainly. Its current limited adoption comes down to higher manufacturing costs right now, and the significant R&D investment needed to integrate it. So yeah, AMD and Intel choosing to stick with GDDR6 for their current lineups is almost certainly a cost-saving move. Helps them keep their GPU prices competitive.
Makes sense. It's that tiered adoption again.
Exactly. GDDR7 will follow that typical curve, high-end first. Then over the next few years, as manufacturing gets cheaper and yields improve, we'll see it trickle down to more mainstream GPUs. It's expected to be the standard through the rest of the 2020s, probably into the early 2030s even.
Okay, so wrapping this all up, what does this mean for you, the listener? Whether you're just learning, you're an enthusiast planning a build, or just trying to keep track of where tech is heading.
Yeah, let's summarize. Bottom line for system memory. DDR5 is absolutely your current mainstream standard. It's capable, prices are good. If you're building or upgrading today or in the near future, DDR5 is the smart choice. While DDR6 is coming and it promises truly revolutionary performance, widespread availability for regular PC users is still, realistically, a few years out. You're likely looking at late 2026 at the very earliest for seeing it in systems, with broader adoption really happening through 2027 and beyond. The whole ecosystem CPUs, motherboards needs to catch up, and production costs need to come down for it to make sense for most people.
And for graphics.
For graphics, GDDR6 is absolutely the pervasive, dominant standard right now across the whole industry. Any idea that it's not widely used is just, well, inaccurate. GDDR7 is the future, a big leap, yes. But right now, it's exclusive to NVIDIA's absolute top-tier cards because it's new and expensive to make. It will become more common, but it'll follow that gradual path like previous GDDR generations did as manufacturing matures and costs fall.
And tying this all together, there's sort of one bigger trend influencing all these memory roadmaps, isn't there?
Yes, absolutely. We can't ignore the elephant in the room. The absolutely burgeoning demand for high-bandwidth memory, HBM.
Right, stuff used with AI chips.
Exactly. HBM is that specialized stacked memory you find right next to powerful AI accelerators and high-end GPUs in data centers. The AI explosion and data center expansion are driving incredible demand for this stuff. And this huge demand for HBM acts as a massive catalyst across the entire DRAM market. It's pushing manufacturers to prioritize developing and producing these advanced memory technologies. And indirectly, it's probably accelerating the push away from older generations like DDR4. This whole dynamic ensures we'll keep seeing rapid innovation in memory performance. But the initial adoption will definitely be prioritized for those high-value, performance-critical applications like AI first.
So something for everyone to think about as you plan your next system or just ponder the tech shaping our world. Consider this. How might the strategic choices of these huge memory manufacturers, heavily influenced by the almost insatiable demands of AI and big data, end up dictating not just what cool new components become available, but maybe more importantly, when that cutting-edge tech actually becomes accessible and affordable for everyday users like you? Definitely something to mull over until our next deep dive.